wondered why in the freezing cold of winter, when rivers are frozen and lakes are covered with ice, some places on earth still release hot water from beneath the ground? What secret force inside the earth keeps that water warm? Today we are diving deep, literally, to uncover the astonishing science behind this natural wonder that has been puzzling humans for centuries. Beneath the ground we walk on lies a world of intense heat at Earth's center. The core burns with temperature exceeding 5000 degrees Celsius, as hot as the surface of the sun. This heat comes from radioactive decay and residual energy from Earth's formation billions of years ago. Now imagine this heat slowly rising upward through layers of rock, roots, and pests called geothermal energy. That's the main reason underground water can stay warm even when the surface freezes. When it rains or snows, water seeps down through the cracks in the Earth's crust, sometimes hundreds or even thousands of meters deep. As it travels downward, it gets closer to hot rocks and magma chambers. The deeper it goes, the warmer it becomes because temperature increases by about 25 to 30 degrees Celsius for every kilometer of depth, a phenomenon called the geothermal gradient. At a certain point, the water becomes so warm that it starts rising back towards the surface, finding cracks or weak spots to escape through. When it finally emerges, voila, we see hot springs, geysers, or steaming wells even in the coldest winter. You might ask, if hot water flows year-round, why do we notice it especially in winter? The reason is temperature contrast. In summer, when the air is warm, the difference between air temperature and water temperature is small, so we barely see steam. But in winter, when the air is icy cold, the escaping hot water instantly condenses into visible vapor, creating their magical steam effect. So it is not that hot springs appear only in winter, it is that spring makes their hidden heat visible. Iceland, famous for natural hot springs heated by volcanic activity under this crust. Japan, the land of onsen, traditional hot baths fed by underground geothermal water. Yellowstone, USA, home to over 10,000 geysers and hot springs where groundwater meets magma just below the surface. Pakistan and India in the Himalayas, places like Manikran and Tatapani show how tectonic heat can warm underground water even in snow-covered regions. Let us break it down scientifically. Geothermal energy source: heat from the Earth's mantle and core moves upward. Convection currents: these heat waves create natural convection, carrying warmth upward through cracks and porous rocks. Groundwater pressure: when heated water expands and becomes less dense, so it's pushed upward through the crust, sometimes violently as in geysers. Thermal equilibrium: the system maintains balance. Cold water seeps down, hot water rises, a beautiful example of Earth's natural physical in motion. Why does not it cool instantly? Because underground rock act like insulators. Just as the thermos bottle keeps coffee hot, the deeper layers of rock trap the heat and release it very slowly. So even when the air above is -10 degrees Celsius, the water coming out of the ground might still be 50 degrees Celsius or hotter. Did you know this same natural phenomena is now being used to generate clean renewable energy? Countries like Iceland and New Zealand tap into underground heat to produce geothermal electricity, a sustainable alternative to fossil fuels. So every time you see steam rising from the ground in winter, remember that is planet Earth's heartbeat, its natural energy pulsing just beneath your feet. The next time you walk through a frosty winter morning and see steam rising from the ground, don't just admire the view. Remember, it is a window into the fiery engine that keeps our planet alive. Remember that even in the coldest moments, Earth's inner warmth never dies.